We have made it to week 11, just one more week, and we get a nice little break. So let's start with a quick warm up, and then we'll talk about what we've got this week. We've got a formative and a summative, and then we will get right into it. So just a little review from the last couple weeks. If I am given that two angles are congruent, how can I prove that those lines are parallel? As a little reminder, kind of thinking about proofs and some of the properties that we learned. If angle 1 is congruent to angle 2, basically, what is their relationship? Hopefully you guys said that these are alternate interior angles. So since we are given that the angles are congruent, remember the way that we prove lines parallel? Hopefully you remember that that was the converse of the alternate interior angles theorem. Now again, if I would have been given opposite, if I would have said A is parallel to B, and then I would have said, how is angle 1 equal to angle 2? Then you would have just said by the alternate angles, interior angles theorem. But again, if we are trying to prove the lines parallel, knowing that angles are congruent, that's when we use the converse. So again, the difference between just the converse and the alternate interior angles theorem. Just thought I'd throw that out there in case people are retaking or you're working on doing some advanced proofs or whatnot. So moving on to our content for week number 11, we have got two things this week. We have got a formative 5.1, which is multiple choice. Okay, it's multiple choice. It deals with really just the notational piece for what we're going to do in 5.4. So you do need to pass the 5.1 multiple choice with an S. Once you do, you will see 5.4. So you will not see 5.4 until the 5.1 is a score of an S. So we're going to look at notation for congruent triangles and how to label things, because then we're going to use that in 5.4 to actually work with and solve problems that involve triangle congruences. So here is kind of what we have for the week. Again, 5.1 and 5.4, proving triangle congruence. Really our essential question, I know this kind of got cut off a little, sorry. Our essential question is, how do we name triangles congruent? We're just going to leave it as simple as that. There are some more in-depth things we are going to talk about in terms of helping us with the notation of that, but again, we will get into that. So since it is a multiple choice and it's not something we necessarily always talk about or review, but it is on a lot of standardized tests, questions 8, so on 5.1, questions 8, 9, and 10 are going to deal with factors. Okay, just like the rest of our multiple choice that has some ACT review on it, this one has 3 questions dealing with or surrounding factors. So can you find the list of the factors? Can you name a factor? You know what a factor is. So here's what a factor is. A factor of a number is basically a number we can divide evenly out of the given number. Okay. So there's some long steps down here, like beginning with the list, starting with 1. Can I divide 1 out and work all the way up to that number that we're trying to find the factors of? So if I were trying to find the factors of 18, for example, I could say, could I divide 1 out evenly? Yep. Could I divide 2 out evenly? Yep, right, 18 divided by 1 works, 18 divided by 2. Can I divide 3 out evenly? Yep. Does 4 divide out evenly? No. 5? No, we already know that. 6? Yeah. 7? No. 8? No. 9? Yes. Yes, yes, yes. And then once I get halfway, I just know that my final number is in. So you could start that way. Another option is just to find your pairs that multiply together to give you the 18. It's going to give you your list of factors. But again, a factor is just a number that divides out evenly as a whole number out of our given. So again, if I'm thinking pairs, I think 1 times 18 is 18. 2 times 9 is 18. 3 times 6 is 18. Does 4 work? No. 5 work? No. 6 times 3, oh yes, but I already have it in my list. So my list is 1, 2, 3, 6, 9, 18. Hey, my same list that I had before. I kind of like this only because it seems like it cuts the work in half. But again, you can go through starting with 1 all the way up to 18 and also do that. So if you want to pause and find the list of factors of 60, let's just practice, because again, being multiple choice, one of the questions is going to say, what's the list of factors of this number? Is this number a factor of 60? Which of these numbers is a factor of 100? So those are going to be the kinds of problems you're going to see. So as long as you can list the factors of a number, you're going to be able to answer those questions. All right, so I'm going to do my way. 1 times 60, 2 times 30. I know 3 times 20. Does 4 work? Can I do 60 divided by 4? And I can. 4 times 15. I know 5 is going to work. 5 and 12, because it ends in a 0. I know 6 works. 6 and 10. Does 7 work? 60 divided by 7? No. What about 8? No. 9? No. But 10 works, but 10's already in my list. So since I now have 10, I can just swoop this little list around. And my list of factors for 60 would be 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, 60. Whoops. So if I gave you a multiple choice and I said which of these, for example, is not a factor of 60, well, make your list of your factors of 60, and then you can easily see that, oh yeah, 45's not. Or you could have said, well, can it be divided evenly? It's another way to check. So again, questions 8 through 10 are dealing with being able to figure out what my factors of a number are. So again, a factor is a number that divides out evenly. So let's start by pausing and writing down what our title is for the week, what we've got for work, our essential question, and that for 5.1, 3 of your 10 questions are just going to deal with finding the factors, and write the way that makes the most sense to you down, okay? If you just like to list them and divide 1, divide 2, divide 3, go ahead and do that. And when you're ready, press play, and then we'll look at some notation for congruent figures. Okay, so questions 1, 2, 3, 4, and 7 are all going to deal with properties of congruent figures. So they might be 3-sided, might be 4-sided, but it's really talking about the notation and how I know what parts are congruent. And it really is going to depend on the corresponding parts that were given. So I'm going to zoom this in a little just so we really have a full understanding of what's going on and how we know what angles and what sides are corresponding and therefore congruent on these figures. So the first thing we have to remember or note from previous weeks is the little tick marks. So if we are given a 1 tick mark on both problems, that means those are going to be congruent. So AB is congruent to DE. So let's say we were just given that. AB is congruent to DE, okay? And then we also know, or they are giving us 2 tick marks here and 2 tick marks here. So that's saying that BC is congruent to EF. And then last but not least, if we have 3 tick marks, with the 3 tick marks, we know those are congruent. So AC is congruent to DF. So here's the deal with this. If we are only given congruent parts, we can write a congruence statement based on the sides or angles we know are congruent or corresponding. A congruence statement tells us everything from the entire figure that's congruent. So if I said A, B, C, the order of writing a congruent statement, it really does matter here. So if I start at A, that means I'm starting between the pink and the green dot. So I need to start with D in my second one. And did I? Absolutely. A here, D here. Okay, then I moved to B. So I moved across the green line to B. So if I did that on my first one, I would need to move across the green line to E on my second figure in order to really write a congruent statement. And then from there, I went to C. So I went down the blue line. So I'd need to go to E, from E to F. To C, I went to F. So when we write congruent statements, they really have to align with what my corresponding sides and what my corresponding angles are. So if I'm given congruent sides or congruent or corresponding angles, I can write the congruence statement. So for example, here, if I would have just been given instead angle A is congruent to D, sure, great. If I would have been given just that B was congruent to E, yeah, great. And then if I was just given that C, the three angle markers, that C was congruent to F, that would still help me write my congruence statement, because I know the A has to come first and the D has to come first. The B has to come next, so the E has to come next, and then the C has to come last, and then the F has to come last. And those would be the triangles that are congruent. So we can start with corresponding sides and angles and write a conditional statement, or we can also go backwards. If I'm given a congruence statement, so again, this is still a congruence statement. If I'm given the congruence statement, I can work backwards and also figure out the sides and the angles that are indeed corresponding and congruent because of the way they label them. So they did this by color. So they said P is up here. It's listed first. W is listed first here. So I know P and W relate to each other in terms of the angle. Okay. P and W. Same with in blue. They say that Q is second and X is second. So I know that Q and X relate to each other, which then also tells me that the length between P and Q and W and X relate to each other in terms of a side. So the order that they list the vertex points or the sides, or the order in a congruent statement, tells us what angles and sides are congruent. And by knowing angles and sides that are congruent and corresponding, I can write my congruence statement. So the order of the vertices, basically this is what I want us to make sure we understand. The order of the vertices in a congruence statement tell us what sides and angles are also congruent. That is huge to know. So does this picture make sense? So I would say I know this, and I would kind of color code and write at least one of these down, because again, the order in which we write the congruence statement and the order in which we label the angles and sides is going to tell us what's congruent. And that's what you're going to do in questions 1 through 4 and question number 7. So pause and write that down, and then let's try some. So for example, questions 1, 2, 3, 4, and 7 are going to be things like this. To prove that you can use the congruence statement to name corresponding sides and angles. So given this congruent statement, again, this is just an example like questions 1 through 4 and 7. Can you name all the corresponding sides? So I'm going to say PQ is congruent to, the first 2 is congruent to the first 2. The second 2 letters, QR, are congruent to the second 2 letters in the second image. The first and last, or last and first, is congruent to the last and first in the second image. So this gives me the sides. What about the angles? Again, that's notation for angles. First letter congruent with first letter. Second letter congruent with second letter. And third letter congruent with third letter. So even if the images, if we're given a picture and they're like spun around, we'll still know the sides and the angles that are congruent, either by congruent markers or by taking our congruence statement, we can tell all the sides and angles that are congruent to each other. So now already we've gone through 8 of your problems on question or on the 5.1 form. Again, this is really just testing to make sure you understand notation, because then we're going to use it for 5.4 to name and write congruent statements and solve for missing sides and things like that. So we still have to know the notational piece of it first. So if you want to write that down, go ahead, pause it. Again, just another example. And then let's look at an example that takes it a little step further, something like 5 and 6. Questions 5 and 6 give you a congruence statement, but then they say to solve for x. So we're going to have to kind of see what we know and see if we can set up some equations using what we know about our notation. So if you want to pause and try 2 of these first, great. When you're ready, press play and let's just go through them. So it gives us that ABC is congruent to DBC. So to me, I know that A and D are congruent, fine. Obviously, I know C and C are congruent. And this B and this B are congruent. Okay, that's great. So how does that help me find the value of x? Well, the only x I have in there is a 2x minus 16, right? And that's a 90-degree angle. So I know I'm going to set that up to the equal to the other c, which is 90 degrees. So basically, we're seeing what's congruent. And then we're going to set up an equation to solve. Does that make sense? That's what we're doing here for this first one. So now I can solve for x. I'm going to get rid of the minus 16 by adding 16. So I have 106. And then I divide out my 2. So right away I have my x is 53. Right, what about for the second one? Again, it gives me that ABC is equal to or congruent to DEF. So A is congruent to D, got it. B is congruent to E, and C is congruent to F. But I want to find the value of x. So I want to find, so here's how I would look at this. I would say I want to find the value of x, which is here, which is side AB. AB relates to DE. So 2x minus 2, the AB, is equal to DE, which is 6. Oh yes, now I have another equation that I can solve. I add my 2. 2x equals 8, divide by 2, and I get x is 4. I've got my answer. So most of these are just going to be asking notation or which angles are congruent, but 5 and 6 actually then ask you to take which angles are congruent based off of our statement. Write an equation and solve. So if you need to write one of those down, I totally would. But 5 and 6 are asking you to do that. And once you're ready, hit play. And what we're going to do now is we are going to move into 5.4, which is really the meat and potatoes of this unit. It's looking at different ways to solve. Well, first we're going to prove that two triangles are congruent. And I don't know why the notation looks a little goofy here, so let's fix that up. So the first postulate or way we are going to be able to prove that two triangles are congruent, it's called SSS. That would be side, side, side. Side, side, side. What that means is all three sides of one triangle are congruent to all three sides of another triangle. So what that might look like is, I might give you these two images. And I might say these are congruent, this is congruent, and these three are congruent. Now, if I label those, what am I given? I'm given a side, I'm given another side, and I'm given a third side congruent, because three sides of one triangle are congruent to three sides of another triangle. I know my triangles are congruent. So basically, if I'm given any of these, if I know any of these are true, I know the triangles are congruent. It's a proof. So to kind of fill this in, I know this turned out a little light. The postulate name is here. The actual postulate is here. And the example is here. So side, side, side is just saying three sides are all congruent. The second way we can prove two triangles are congruent is through side, angle, side. So here's the tricky part about side, angle, side. And I'm going to write it in a darker green. The congruent angle has to fall between the two congruent sides. Like, that's so important. It won't work otherwise. But what that would look like is same thing. So if I gave you this picture and I said this side is congruent to this side, these two sides are congruent to this other set of sides, the only angle that's going to work is going to be the angle that is made by connecting these two congruent sides. So this right here would have to be my congruent angle. So here I would have a side, I have an angle given, and I have another side. Notice that A is smushed in between the two sides. Since it is, I know this is a side, angle, side. And the third way we are learning today to prove two triangles are congruent is if we have angle, side, angle. Again, craziness, but the side has to be between the two angles. So what that looks like is this. If I know this angle is congruent to this angle, these two angles are congruent. The only side that could possibly be congruent in order to use angle, side, angle, so that the side is between the two angles. The congruent side must fall directly between the two congruent angles. Would be this guy right here. Because then you have an angle, you have another angle, and look, directly between them is a side. If the side would have been somewhere else, we could not use it. Order matters for these. So this is really the meat and potatoes and the chunk of our notes that you want to write down. But in addition to that, I also have some steps to help you out. Here are some helpful hints to labeling things congruent, because, and we're going to go through this in a minute, but I want you to just pause and write it down first. We aren't always given or labeled the things that are congruent. So first look and see what sides and what angles we are told are congruent with angle markers and tick markers, and just write the S and the A over there, kind of like I did in the example column. Then though, you also have to look for any unmarked congruencies labeled S or A. Okay, so angles might be vertical angles are congruent. We know for parallel lines, alternate interior and alternate exterior angles are congruent. They may not be marked, but we know that they are congruent. We know if a shape shares a side, just like in our last example, they shared the 90-degree angle. It's going to be a congruent side. So I would write down that for 5.4, I'm going to make this a little smaller. Get this chart down so you have the ways that we are naming and labeling triangles congruent. Again, if I know any of these, I know that the two triangles are congruent. But I would also write down all of these helpful hints. And again, we leave a little space next to the helpful hints so that we can indeed write an example or draw an example next to it so you know exactly what it means. You're going to want to use this list of helpful hints as we write and draw things out, mark things congruent, especially when we first get started until you get the hang of it. So write this down. Leave space to make some additional notes. And when you are ready, press play. So for an example here, in this example, you would only need to know that 3 congruent sides are shared between the two triangles to know that the triangles are congruent. So you might say, well, how am I going to, and again, you already wrote this down. You wrote down what the side was. You wrote that if 3 sides of one triangle is congruent to 3 sides of another, then the whole set of triangles is congruent. Everything about them is the same. A side the same here, a side the same here, and a third side the same here. Okay, we already wrote that down in our notes for side, side, side. We have 3 sides that are congruent. But how would I use it here? Just to kind of verify. This says these 2 sides are the same. These 2 sides are the same. But how would I explain then that, where's the third side? In other words, where is the third side? How would I know that these are congruent by side, side, side? And if it helps, note that it goes from A to B, D to B. Oh yeah, they already told us that. But then it also goes from B to C, oh, and B to C. How do I know that these 2 sides are congruent? What would I say that as? Hopefully you noticed they are a shared, in above when we wrote down some little helpful hints and I said, oh, well, if they have a shared side, we got to label them congruent. This is what a shared side is. So if you are confused on what that means, I would write this example down. Huge. How are we going to use side, side, side to explain these are congruent? Well, BC and BC is a shared side between both triangles, right? It's a shared side between this triangle and it's a shared side between this triangle. They share from the left on one, the right on the other. Since they are the same side, we can mark them congruent. So now we have our 3 sides to prove these are congruent. Another little definition that might be helpful is included angle. Again, the last 2 are included side. Said that we needed, for side angle side, the angle needed to be in between the 2 congruent sides. That means it's the included angle. It's inside the angle. Same with the side. The side had to be in between the 2 congruent angles. That's the included side. So again, included is just what's created. So if this were one side, this were a second side, the included angle is the one that's formed or in between those two congruent ones, right? I create or draw in that angle by tracing my congruent sides. So again, another example. How can we show or explain that these two triangles are congruent by side, angle, side if I'm only given that one side and another side are congruent? How am I to prove that side, angle, side is how these two are congruent? In other words, what's not marked that we know is true? And hopefully you saw that in order for these to be congruent, this angle right here had to also be congruent because it's included. The angle has to be between the two sides. So by vertical angles are congruent, we have a side angle side congruence. Okay, let's take a look at one more. So how would I explain I'm going to use angle side angle to prove these are congruent? I'm given an angle up here. I always label. Remember my steps say label any angles or sides. What else do I know? My steps said label any angles or sides you are given congruent. Then it said, going way back here to reference, label anything that's not marked. So do I have vertical angles, a shared side, or parallel lines that form congruent angles? Well, I have a shared side. Okay, I don't have parallel lines, so I can't, again, parallel lines would mean that I'm forming angles like this. I don't have parallel lines, so I can't use any of those. And I don't have vertical angles because vertical angles are lines that cross each other and they're the insides of the V, or I'm sorry, the X. Now this would be labeled as a AS. Why can I not use this to prove ASA? Where does the side fall? And hopefully you said, well, the side is not in between the two angles. That would be our explanation, right? The side is not included or does not fall between them. So what does this look like in a proof setting? And then we'll get into problems that you are going to have a peek at on your assessment for the week. But let's just take a look at this proof real quick, and then we'll pause to write some things down after. All right. So I am given that BC is parallel to AD. That's given. So then how do I know that CBD and it should be ADB are congruent? That was written backwards. How do I know that those are congruent? Hopefully you said, because I know that parallel lines are congruent, the angles are congruent because they are alternate interior angles, right? So that was one of our kind of our lists. What about BC is congruent to AD? So BC, so we know those angles are congruent. BC is congruent to AD. Oh, that's given to me. Okay, but then how does that tell me, or how do I know that BD is also congruent to BD? That's a shared side, isn't it? So again, even if things aren't labeled for us, we need to be very well aware that we can say that angles and sides are also congruent by vertical angles. Again, here's what those look like. By, if we have parallel lines, alternate interior and alternate exterior angles. Okay, also by a shared side. So those are the three, and that's why you want to use that chart to help you list or label other pieces that are congruent, because even though they weren't labeled here for us, we knew they were congruent, and we could use it to prove the triangle's congruent. So it's not always just going to be what they give you. It's going to be a combination of what they give you and what we know. So in 5.4, some are multiple choice, some you're doing and explaining. Questions 2, 3, 4, 5, and 6. 5 of your 10 questions on here are going to basically say, are these congruent by side, 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 angle, angle, or none of the above? So what you're really doing as you're doing questions number 2 and 3 and 4, 5, and 6 is you're looking at what you are given and what we can draw in. So 1, label sides and angles congruent that are given to us. That was step 1. You don't have to write these down on the side because we already have this. This is step number 1 in that list of helpful hints, but I'm going to do it. So step number 1, I'm going to say these sides are congruent. They also give me these angles are congruent. Now step number 2 would be label any additional sides or angles congruent by, do I have any vertical angles in that first one? In other words, do I have 2 lines that cross that can create those inside Ds? No. What about parallel lines? So alternate interior angles or alternate exterior angles. The only way that's going to happen is if I have parallel lines cut by a transversal. I am not given these are parallel, so I cannot use that. So the last thing I'm going to look for is a shared side. Do I have any shared sides going on here? And I do. This side is congruent to itself. So now what I have here is I have another side. So just pulling one of these triangles away to make it easier to see. This is the side, this is a side, and this is an angle. Can I say that this is side, either side, 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 or angle, side, angle? Can I say these two are congruent by one of those? I have 2 S's and an A. Can I say this? And hopefully you're saying, no, you can't, only because the A is not in between the 2 S's. In order for that to be true, this would have to be our angle right here in yellow. So why don't you pause this, work through what we are given, label what we are given with S's and A's. Label any additional S or A through vertical angles, parallel lines, or shared sides, and then see if you can use one of these methods to prove these triangles congruent, because that's what 5 of your 10 questions on 5.4 is going to deal with. And once you're ready, press play to go through these. Okay, so right off the bat, I know that a side with a length of 4 is congruent. A side with a length of 3 is congruent. And I know that right angles are congruent. So I label what they gave me. Then I move along and I don't have any vertical angles, I don't have any parallel lines, and I don't have any shared sides. They're 2 completely separate figures, so I am done. Now what I see is S, A, S. Is the A falling directly between the 2 congruent sides? And it is. That's our answer. If we move on to the second one, I'm given a side is congruent. and given an angle here is congruent, I'm also given these outside little guys are also sides that are congruent. I labeled what they gave me. Labeled what they gave me. Do I have any vertical angles? No. Do I have any parallel lines? Remember the parallel lines shown by the little arrows on the line. So no. Do I have a shared side? No. So what I have, if I pulled this aside, is I would have a side here, and an angle here. Is the angle between the two sides? Nope. All right, last one. I have a 4 with a 4, a 6 with a 6, and a 7 with a 7. So side, side, side. Hey, that's one of my rules. I know these are congruent by side, side, side. But even though some of these are multiple choice, grab a piece of paper out. Make sure that you're labeling everything you're given and that you might not be given, but know, so you can accurately label these triangles congruent or not. So pause and write this down so you have some good examples of 5 of these, and then move on when you're ready. So again, what's the postulate? A few more that are similar. What's the postulate that proves these triangles are congruent? Pause and try them if you want. But again, these are very similar to the 5. So I know angle, shared side, angle. Hopefully you guys said angle, side, angle. For the second one, I have a side. I have an angle. I have another side. How it is right now, I don't love it. But wait, shared side. So I actually can do angle, side, angle, or I could do side, 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 because I know 3 sides as well. For the last one, I have a side. I have a second side. Since these two are congruent by vertical angles, so are these two. So I have angles. Ooh, I have a shared side as well. So I could do side, side, side here. I could do side, angle, side here. So again, 5 of those 8 questions on 5.4. 5.4 is 8 questions. Some of them are multiple choice, some of them aren't. I think it's half and half, okay? Half of them will require explanation. But 5 of those 8 are going to ask you to be able to use these hints to label what we know and what we're given to see if these 2 figures are indeed congruent. Being specifically careful about the order that we see the angles and sides. 2 more of these really deal with a rule called CPCTC. This is our last thing we are going to talk about today. Questions 1 and 8 deal with something, and we've done something similar to this before. CPCTC stands for the corresponding parts of congruent triangles are also congruent. We did corresponding parts of congruent figures were congruent in the past. But now we know that if we are given, basically, if we are given or know that 2 triangles are congruent by side, 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 angle, side, or angle, side, angle, we can use CPCTC to prove that all the rest of the parts are congruent. So in my own words, I like to say, if 2 triangles are congruent by either side, 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 angle, or angle, side, angle, I know all of their sides and angles are congruent by, and the reason is CPCTC. So, hey, I know the triangles are congruent, so then my reasoning for everything else being congruent in these is CPCTC. Again, so here's what I would write down. Noting that CPCTC stands for the corresponding parts of congruent triangles are also congruent. And I would write that that is like questions 1 and 8. And then press play, and then let's actually do a couple using the CPCTC rule so you can see how to apply it for your problems. Okay, so it says A and B are on the edges of a ravine. First of all, what's AB, or how am I going to figure that out, and how are you going to explain it? You might look at this and you might say, well, I know it's 18 because they're both on the outskirts, right? We don't know that for sure yet, though. How can we prove it? So I am given that this side, I'm going to actually erase. So watch what I'm going to do here. I know that 10 and 10 are congruent, so that's a side. It also tells me that 15 and 15 are congruent, so a second side. Okay, big whoop. I got a side and a side. But by writing congruent by unknown or unlabeled pieces, I know that these angles are also congruent by vertical angles. So our answer would not be they're the same because the triangle. We would have to say, oops, sorry about that. We would have to say that there are vertical angles that make these triangles congruent by side, angle, side. Or because we have vertical angles, the two triangles are congruent by side, angle, side. Therefore, by CPCTC, I now know that this side is congruent to this side. Just saying what it's equal to is not going to be good enough. So you're going to have to first prove the triangle's congruent, right? And then, because even so, we're given a side here, side here, side here, side here, angle here, angle here. I was never told that these two were the same yet, but we know they are by CPCTC because all of the corresponding parts of congruent triangles are also congruent. So that's how we know that AB is 18 miles long. So let's try a couple more. What about this one? 7 and 8 are going to ask you to fill in just pieces of a proof, and you can write this down once we do them. But let's do 2 of them, and then you can pause and write down. Here's what we know. We know that NO is parallel to MP, and we know that angle N, great, is congruent to angle P. But we want to prove the other two sides are parallel. Okay, so we wrote in our proof what the given is. How do we know that NOM, I'm doing blue, NOM, this angle, is congruent to PMO. It's congruent to this angle. If we know the top and the bottom are, it's not labeled, so my options are going to be either vertical, right? Alternate interior or alternate exterior because of parallel lines, or a shared side. Again, if it's not labeled for us, we know it's got to be one of those three. And we know the lines, the top and the bottom, are parallel, so I'm going to say these are alternate. Interior angles theorem tells us that these are congruent. It also says that MO and MO are congruent by the reflexive property, or just a shared side. If you had to fill that in, I would love to see shared side. So then how do I know these two triangles are congruent? Here's the thing to be careful with. When naming triangles congruent, we use either side, 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 or angle, side, angle. So what do we have here? We have angle, M-N-O, we have an angle, another angle, and we have a side. It actually doesn't end up being one that we did. Oh, poopers. But that's okay. This is still another way down the road we will learn. But angle, angle, side. So wait, here's the question. So we use one of our ways to prove triangles congruent, but what about after that? Once we know triangles are congruent, what do we use to prove the rest of their parts are? This is the one I was getting at. So let's say they actually told you this and you weren't filling this in, because you won't have to fill one in. That's not what we don't know. So no worries there. So let's say we were given that this was angle, angle, side. But again, once you know that the triangles are congruent, the next reasoning is going to be CP, CTC. So same with this one down here. To name the triangles congruent, we're going to use side, 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 or side, angle, side, or angle, side, angle. So again, it tells us J is the midpoint of KM. So we know that these are congruent. It's also the midpoint of NL. Well, that means that these two are congruent. Okay, great. It also says, oh, by definition of midpoint, those two things are congruent. What else do we know? How do we know that KJL, this angle right here, and MJN, this angle right here, how do we know that those are also congruent? Again, there are unlabeled pieces. So we're going to say, oh, by vertical angles. Whoosh. So then how do I know that these two triangles are congruent? If I label them, I have a side, an angle, and a side. The angle falls between the two congruent sides. So then how can I name that any other part of these triangles are also congruent? Once I know triangles are congruent, I know all their other parts are congruent by C, BC, T, C. Ooh, 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 ooh. So I would write that down. That's important from both of these. Again, we're going to name them congruent by this, but once we know they're congruent, we use C, P, C, T, C. So go ahead, pause that recording, finish your notes, write any questions you have down so we can go through them in class this week. And then I will see you in class. Have a wonderful day.